Good afternoon, and welcome to your Science Review with Mr. Blades. Today I'll be going over an example I did today in class using some position versus time data, calculating distance versus time data, then plotting that information on a graph, and then analyzing that graph with algebraic methods. Now you can see over here that I have collected some experimental position versus time data. You can see this from my table that I started at position equals 8 and headed towards position equals 1. My position versus time table shows that my position, is measured in meters and my time is measured in seconds. Over here you will see I have my distance versus time table, and it is also measured in meters versus time in seconds. Okay, so now what we're going to do is we're going to take our position versus time data and turn it into distance versus time data. All right. Now the way we're going to do this is, at time equals 0, at the very beginning where we started paying any attention at all to the movement of the object, we're going to notice that the distance is 0. The distance of our car at time 0 will also be 0. But now we have to do some math to figure out how far the car goes from 0 to 2 seconds. And we're going to do that by taking 8 minus the 6.4 that I measured at 2 seconds in. And that is going to be 1.6 seconds. Okay, so you can see that I filled out my distance versus time table with the arithmetic that I showed you just a second ago. So now let us use our data and plot it on a position versus time graph and a distance versus time graph. So this is going to be something you probably remember from algebra, but let's go ahead and do it rather quickly. So for our first data point on our position versus time graph, we have 8 for position in meters and 0 for our time. So we're going to go ahead and put a dot right here at 8, 0. All right. Next, we're going to plot 6.4 at 2 seconds. So we have right there 2 seconds and 6.4, so just a little under 6, and so on. Now we're going to do that for the rest of these data points: 4.9, 4.9, 3.2, 1.5, and 0.8. We're going to do our best to draw a line that connects all of these. Now, these dots do not all lie perfectly on a line. What we just did is we drew what is called a best fit line. That is a line that does its best job to incorporate all of the different points. We are going to use this line in a little bit. But let us graph now our distance versus time graph. Essentially, we do the same thing, but again, our distance only adds up in one direction instead of taking direction into account over here. So we have 1.6, 3.1, 4.8, 6.5, and 7.8. And again, we will draw a best fit line, a line that does the best job we can to incorporate all of those data points. So now I'm going to erase all this, and I'm going to show you how we can analyze our data. And if you remember from earlier lectures, delta y just means the change in y, and delta x just means the change in x. So we are going to take the change in y over the change of x. Another way to write this is y2 minus y1 over x2 minus x1. Now, it doesn't actually matter which 2 points you use when you do this equation. The only thing that matters is that you use the x and y from the same point. All right? So let's go ahead and use this set of points and this set of points just for fun. So our x2 is our y2 is 1.5, and our y1 is 6.4. Our x2 is 8, and our x1 is 2. So when we go ahead and do this math, we have 4.9 minus, or over 6. Now, can you guys see which mistake that I put in here? You're right. I left out a negative. All right, so what we have is 4.9 divided by 6. So I don't have my math on me, but 5 over 6 is 8.33 or 0.8333, and that's pretty close. So I'm going to go ahead and just write that negative 0.83, and that is our slope. And now that we have our slope, we can go ahead and finish off our equation for this line. So we have our slope, and now we just need to find out our y-intercept. And you can tell from our table that at x equals 0, at time equals 0, our position value is 8. So our b is just going to be 8. The proper equation for this line is then x in meters is equal to negative 0.816 multiplied by time plus 8. That is the equation for our line. But did you see what we actually calculated when we calculated our slope right here? The slope of a position versus time graph is our velocity. So we've taken experimental data on position versus time. We have calculated distance versus time and plotted it in a table. We then graphed our experimental data, position versus time, and distance versus time. We then used that data to calculate the slope of this best fit line and its overall equation. That is about all you can tell from that particular set of experimental data. So I hope this was helpful for you, and I'll see you in class.